Hi, I am Anita Oberhoster. I'm a cooperative extension specialist in enology in the Department of Viticulture and Enology at the University of California, Davis. I specialize in wine chemistry and have been fortunate enough to see the winemaking process all over the world. This area where I'm standing today is part of the vineyard-rich region of Northern California in the United States. The natural beauty of this vineyard is a testament to the timeless art of winemaking. But however timeless, over the millennia, winemaking has undergone some notable changes. Since our ancestors first stumbled upon the first glass of wine and the concept of fermentation, winemaking has evolved into a modern art that leverages the technologies of the 21st century. Nowadays, technologies like machine harvesting, automated bottling, and advanced lab testing equipment are available to increase the efficiency and intricacies of winemaking. Regardless of the technologies that a winery chooses to adopt, every winery follows wine's natural scientific formula, namely fermentation. During the fermentation process, the sugar in the grapes is consumed by yeast and converted to alcohol, heat, and carbon dioxide. The released carbon dioxide protects the fermenting juice from oxygen, and in this anaerobic environment, grape juice becomes wine. Wines are generally considered a low microbiological risk product because of fermentation and the resulting product parameters. Parameters like pH, alcohol content, organic acids, polyphenols, and sulfites render the wine free from any pathogens. Today we will take a journey through the general process of commercial wine production and throughout each stage demonstrate the proper processes and controls for ensuring a safe product for the public, all the while emphasizing how wine is naturally a microbiologically safe product. The production of wine starts in the vineyard. Throughout the harvest season, which can begin as early as July and end as late as October, the grapes are picked from the vines. During this time, wineries work around the clock harvesting grapes for production. The winemaker makes a calculated decision about when to pick the grapes. Various indicators like acidity and sugar levels, as well as seed color, firmness of the skins, and berry taste are evaluated to determine the exact picking time. The sugar levels in the grapes, for example, measured in degree Brix, which is roughly the percentage of sugar in the grape, determine future alcohol content. Each gram of sugar, when fermented, will create roughly a half gram of alcohol, or precisely 0.55 to 0.6 grams of ethanol. Harvesting usually begins at dawn while temperatures are low. The low temperatures keep the grapes fresh and the flavors intact. There are two types of harvesting methods used by wineries. The first is machine harvesting. Machine harvesting occurs more often at large-scale wineries, seeking to decrease labor costs and harvest time. When performing a machine harvest, a vehicle moves through the vineyard, straddling and shaking the vines to remove the grapes. The second, more traditional harvest method is handpicking. This method is used by many wineries and is often preferred by winemakers for more valuable grapes, since it is a gentler method and yields a higher return on grapes per row. After harvesting, the grapes are evaluated and any materials other than grapes are removed. This is an important step that workers take to adequately screen the crop for materials such as leaves, twigs, or anything else that is not essential to processing. Let's highlight the takeaways from harvest. Two methods to harvest: machine versus handpicked. Steps to protect the juice are taken very early on. Materials other than grapes, also known as mog, are removed. Within a few hours of harvesting, the vineyard is barren and the grapes begin the journey to the winery. These grapes are offloaded at a receiving area near the fermentation tanks. Processing usually begins as soon as the grapes arrive. The first step in wine processing is transferring the grapes from the large bins to a crusher to be destemmed and delicately broken. After each load of grapes is put into the crusher, the bin is cleaned based upon the facility's standard operating procedure. At this winery, the bins are power rinsed to ensure they are sufficiently cleaned for the next batch. Right before the grapes are crushed, the stems are removed and sent down a conveyor belt. Sometimes wineries choose to evaluate any materials other than grapes a second time on the conveyor belt. During the crushing phase, the objective is to open the grapes just enough to mix with the yeast so that it will induce fermentation in the tanks. Ensuring a gentle crush is essential. A grape that is opened too forcefully could crush the seeds, which would release bitter oils or tannins that create an undesirable taste profile for the wine. Crushing the grapes and removing the stems are steps taken prior to the must entering the fermentation tanks. Must consists of the skins, free juice, and other suspended solids of grape material that results from the crushing phase. Prior to the must entering a fermentation tank, all equipment involved in processing is cleaned and sanitized. Once cleaned and sanitized, all equipment is properly stored. Cleaning and sanitation are critical parts of the winemaking process, and the winemaker understands that all equipment that encounters the juice or wine at any time in the process must be cleaned and sanitized using acids, bases, and oxidizing chemicals. Whenever chemicals are used to clean equipment, a worker takes sufficient safety measures by wearing proper personal protective equipment, also known as PPE. A winery's standard operating procedure would dictate the cleaning of the tank. Many fermentation tanks like these are made of stainless steel, since it is an easy material to clean and sanitize. Oxygen levels are also monitored and brought to a safe level before anyone enters the tank. One worker remains outside the tank while the other cleans and sanitizes the inside of the tank. The fermentation tanks are cleaned and sanitized before and after usage. A winery worker will record the date and time of cleaning and sanitation on a log sheet and the tank itself. Although red and white wine production differ, all cleaning and sanitation concepts and practices are the same. Let's highlight the sanitation practices. Tanks and equipment are sanitized frequently to prevent contamination. Sanitation is part of good manufacturing practices. Equipment is stored in its appropriate locations. In this section, we will focus on how red wine is made. For red wine, the lightly crushed grapes are first moved to a clean and sanitized tank. Once in the tank, dry ice is sometimes added to keep the must cool and preserved. After the tank is filled with the must, fermentation is initiated by adding commercial yeast, a process also known as inoculation. While the wine ferments, the yeast converts the sugar contained in the must into alcohol, or more specifically, ethanol. The ethanol helps extract the grape skin and seed compounds, which give red wine its color, mouthfeel, and taste. This process is known as maceration. Throughout fermentation, the must is mixed or recirculated. This happens daily to help extract color and flavor compounds from the grape skins. Mixing also occurs to keep the temperatures in the tank homogeneous, as heat, which is generated during fermentation, accumulates in what winemakers refer to as the cap or surface of the mixture. The cap is mostly grape skins that rise to the top of the fermenting must due to the production of carbon dioxide. There are two methods for mixing. One is called performing a punch down and the other is a pump over. Both are popular choices among commercial wineries. This worker is performing a punch down. During fermentation, the winemaker makes important additions to the wine. Potassium metabisulfite is commonly added as a preservative to prevent microbial spoilage. It can also be added to the must prior to fermentation. Found in all wines, sulfites occur naturally as a byproduct of fermentation and are often added to prevent oxidation and bacterial spoilage, thereby enhancing taste, color, and stability of table wines. Current federal regulations permit up to 350 parts per million of sulfites in wine. In practice, sulfite levels are far below 350 parts per million. Wine relies principally on pH for preventing the growth of undesirable microorganisms. For this reason, the wine is monitored and maintained below a pH level of 4.6. Many wines have a pH range between 3 and 4, which is very acidic. In comparison, a pH of 7 is neutral, and drinking water ranges from 6.5 to 8.5. The low pH of wine provides significant protection from pathogens. Most foodborne pathogens like to be at or near neutral pH and do not survive below a pH of 4.6. If needed, the pH can be adjusted by adding organic acids. Tartaric acid is a very commonly used additive because it is the most prevalent naturally occurring organic acid contained in grapes. During fermentation, wineries perform lab analysis to monitor fermentation progress as the alcohol content goes up and the percentage of sugar goes down. Outdoor and indoor fermentation tanks are often left partially open to allow fermentation carbon dioxide to escape. Again, this is acceptable as undesirable microbes in the air do not survive inside the tank's environment. When not in use, all outer openings to the tanks and other processing and storage areas accessible to people are adequately secured and monitored. Here a worker is locking the opening of the fermentation vessel. Let's highlight the key food safety takeaways from fermentation. Fermentation is initiated by inoculating with yeast. The fermenting wine is kept at an acidic pH well below 4.6. Most foodborne pathogens do not survive below a pH of 4.6. The winemaker takes routine samples of the wine to monitor fermentation progress. While at the initial stages of fermentation, there are typically different organisms present. By the end of fermentation, only a very few or non-pathogenic organisms survive in the low pH alcoholic environment. Remember that when producing red wine, the mixture in the fermentation tanks is comprised of the grape skins at the top and the pulp and juice at the bottom. After about 2 weeks of fermentation, the juice becomes wine, and the next step is to transfer the wine to a receiving tank. First, a hose is connected to a valve at the bottom of the tank. The hose then pumps the wine through a small strainer to ensure no solids pass through before it is pumped into the receiving tank. This is known as free-run wine. The bulk of the remaining skins from the cap are placed into a basket press. The basket press resembles a jumbo-sized kitchen strainer. Once filled, the skins and other solids are pushed down to free the remaining liquid. The press pushes the solids down in microbursts and can take up to a couple of hours to free all the wine from the solids. Afterwards, the freed wine is transferred from the presser via a hose to the same receiving tank the liquid at the bottom of the tank was pumped into. After pressing, the red wine is left to settle for a few days in the receiving tanks before being moved into oak barrels or another kind of storage vessel. After use, the hoses and processing equipment are properly cleaned, sanitized, and stored on long racks to promote cleanliness. In red wine production, the remaining material from pressing is called pomace. Pomace is the dry, blackish-red debris consisting of grape skins and seeds. Sometimes wineries sell and ship pomace to other facilities as animal feed. Because the pomace was produced following standards of processes for human food, which is more rigorous than the standards for animal feed, it can enter the animal feed supply stream safely after packaging and labeling protocols have been sufficiently followed. The distinguishing feature of white wine production is that contact between the grape skins and the juice during fermentation is minimal. The fermentation process for white wine is typically slightly longer and cooler than it is for red wine. The longer and cooler fermentation helps to preserve the delicate flavor and aromas of the white grapes. All cleaning and sanitation concepts and practices are the same. Let's check back on our red wine. After the red wine has settled for a few days in the receiving tanks, the wine is placed into oak barrels or other storage vessels. Before filling, the inside of the vessel is sanitized based upon the facility's standard operating procedure. At this winery, barrels are sanitized using high-pressure steam and ozonated water. Once the storage tank or barrel is sanitized, wine is moved to the vessel in a manner that separates the naturally clarified wine from the solids on the bottom of the fermentation tank. This process is known as racking. The barrels are filled manually to avoid spillage. Once the barrels have been fully filled, they are stored in a temperature-controlled room. In this case, the barrels are stored at 52 degrees Fahrenheit or 11 degrees Celsius. The wine will be aged in barrels for 12 to 36 months prior to blending to soften the wine. During barrel aging, a small fraction of the wine evaporates. To prevent air contact, which could affect the quality of the wine, the barrel is regularly topped up with more wine during this stage. Additionally, ongoing tasting and analysis occurs throughout the stage for quality control. Let's review the movement of wine to storage tanks and barrels. The vessels storing the wine are adequately cleaned and sanitized prior to use, according to the winery's standard operating procedure. Pipes and fittings are cleaned and sanitized prior to use. The vessels are dated and marked for tracking purposes. The wine is stored in a temperature-controlled room to maintain quality. When the aging phase has concluded and the blend is determined, wines are transferred from the barrels or storage tanks to blending tanks, after which the wine passes through a filter to ensure any remaining solids and wine-related yeast or bacteria are removed. This filtration, the last step prior to bottling, makes the wine crystal clear by removing any solids. Many wineries filter the wine twice before the bottling stage, according to their winery's standard operating procedures. At this point, the wine is ready to be bottled. Bottling is the critical final step in the process, where the utmost care is taken to ensure the tanks, pipes, and filling equipment are clean and sanitized. In large wineries like this, the bottling facility is a complex, highly controlled, automated operation. In addition to complex automated facilities, many wineries use what are called mobile bottling facilities, which are housed in a trailer and moved on-site for bottling operations. Wineries are advised to contract with mobile bottlers who are registered with the United States Food and Drug Administration and have standard operating procedures and good manufacturing processes pre-approved by the facility. During the bottling stage, workers take appropriate protective measures in accordance with their winery standard operating procedure. At this facility, employees wear hairnets and protective eyewear and gloves, called PPE, or personal protective equipment. Also, hand-washing sinks are located around the facility, and wineries require all workers to follow established hygiene protocol. Workers do not wear protective suits in the bottling facility due to the microbiologically safe nature of wine and the standards of procedure that every vessel and piece of equipment has been properly cleaned and sanitized throughout the process. As an extra layer of protection, wineries also filter a bottle from the production line in a lab onto a microplate to evaluate for any foreign material and wine-related yeast or bacteria, in addition to performing full bottle analysis as the final steps to ensure a safe, wholesome wine for consumers to enjoy. The automated bottling line begins with unlabeled, empty bottles on a conveyor belt. First, the glass is blown with a blast of air or nitrogen to clear out any dust or residue. Immediately after, the bottles are filled to a predetermined and checked fill level, and the cork is inserted or cap affixed. Next, foils are fitted onto the bottles prior to labeling. At this winery, the filling and corking apparatus is fully encased to protect the wine from ambient air. The filled and capped bottles move down to the labeling station and then make a final approach to the case. The wines are put in cases, usually by the dozen. Finally, the cases are put on a pallet, saran wrapped, and sent to distribution facilities before hitting the shelves. Let's review the bottling process. All equipment on the bottling line is properly sanitized. The filling and corking equipment are fully encased. Nitrogen is blown into the bottles to remove dust prior to filling. Appropriate protective gear is worn by personnel to prevent contamination during bottling. Wines are filtered one last time prior to bottling. Wineries only contract with mobile bottlers who meet the winery standards and comply with the regulations of the Food Safety Modernization Act. Remember, good manufacturing practices are followed throughout the winemaking process, and there are no known hazards in winemaking that needs a preventative control. Thank you for joining me on a tour of the winemaking process. While the winemaking processes demonstrated in this video may not be fully applicable to each winery in the United States, it has demonstrated a general set of guidelines and processes notable of most commercial facilities in California. I hope you have enjoyed this behind-the-scenes look at winemaking and have learned a little something about what it takes to bring this wonderful beverage to your table.